Hi, Professor. This week has been very interesting looking into AI and advanced systems that are helping scientists break down large data sets. So, the model that I chose for my presentation here is on clustering and utilizing the K means. It's a sorter. So, what is it able to do? In this circumstance, I am sorting environmental data and putting it into smaller amounts of groups to be able to then compare the data set. Um, for the scenario, I focused on land cover change and ecosystem transitions here in North Carolina. I'm very passionate about what is going on here and the changes that are happening in North Carolina environmentally. And this class has been eye opening about that. The examples I'll be using are on Western North Carolina and Asheville, and looking into the type of data and damages that were done during Hurricane Helene, Helen, however you'd like to phrase that. So, being able to group this data into smaller similarities will really help researchers when it comes to clustering this large amount of information and make it readable and be able to identify ecological changes. So, Chapter 3, Section 3.1 discussed how, clustering um, observations can be used and how you can look for those similarities and you can train these advanced systems to find those similarities and then use that information. I think one of the challenges with it is sometimes it may be too simplified, and so that's something they got to look out for. What does the model reveal? So it can group things by the type of forest they are, maybe damaged areas and deforestation, and also where land is being developed. It's able to identify ecological transitions that happen over time because of these reasons. Uh, Satellite data can be collected and it can be categorized to be able to pinpoint different things. I did a previous thing on vegetation, and it's definitely something that can be utilized for that. Uh, it helps narrow down and target what relief efforts and restoration efforts need to take place, especially after something like a hurricane. What are the challenges with that, and what it may hide is, it may not catch everything. It can blur out certain important details, or it just may think something looks like this, and so it either will add it or forget to add it. The scales of how large or small of an area, how the clusters are chosen. So, as you mentioned in your lectures, it's still important for the researchers to do their homework and look into this information before trusting it. Don't trust anything until you've been able to factually prove this information. So, if not, the risks in the real world can be, making poor decisions can be an outcome of this. So, decision makers would be impacted by this. I think the trade offs for it include, simplification. So, as we said, taking mass amounts of complex data and narrowing it down to make it easier to understand. But it's a tool, it's not a catch all, it's not a guarantee. So, it still needs to be prioritized, and that, the results are verified prior to moving forward. Far as like a reality check, you can think about things like, using looking at satellite imagery yourself, doing field observations, so going out there and actually looking into these areas that have been impacted by the hurricanes or other natural disasters or just in general. So you still got to do the footwork in order to make a combination of observations versus collected data. I think that there is a lot of potential with this clustering being combined with other information, and I feel like this is a very valuable topic in North Carolina. So thank you for watching my presentation.